This design borrows from other folks, but the final product is a bit unique. Because I have a SawStop contractor saw, the motor protruding out the back of the cabinet means I couldn't use a normal fold-down table design. I do, however, have a fence that has horizontal slots on the top and the outside. This is key to making this design work. Yes, this table takes more time to set up than the normal fold-down table, but this is the best I could do. I'll walk you through the construction process along with some design considerations. I'll concentrate on the design aspects and where you might need to tailor the design to your situation. I made my table so that it was about 36 inches deep and 48 inches wide. The tabletop is made of 1/4-inch plywood. I mention this now because the overall size dictates the size of some other components. You'll build 2 supports and attach them to the side of the saw's base. Here the supports are already built and bolted to the sides of the base. They are similar, but not exactly the same. You'll need 2 of these folding brackets. Get them on Amazon. Mine are 24 inches long. Have these on hand before you start building. Here you see one of the supports brought up to its up position, where it will hold the tabletop. I needed to add wood to raise the bracket's top to the right elevation. The tabletop is just 1/4-inch plywood with some holes cut in it and a sturdy edge glued onto it. These pieces help to get the part square and matching up during construction and during use. I built 4. The longest one is 24 inches. The others are shorter. They all have the same profile and have the same dimensions for the holes. They are just spaced differently. These are made to quickly attach to the top of the rear fence rail. They can slide to wherever they are needed. I needed multiple sizes because the fence cannot slide over the bridge parts, so I attach as many as I need for a given situation. The 24-inch piece almost always sits on the fence rail to the left of the blade. The bridge parts help you during construction to line up the other parts when making precise measurements and cuts, and they provide a smooth surface so that the cut material can slide over on its way to the main tabletop. This shows the unique profile of the bridge parts. The main body needs to be just thick enough to reach the top of the saw's tabletop when the part is attached to the rail. That notch on the right side is needed to let the part slide past over some mounting hardware. You may not need this. The part is attached to the fence rail by first drilling some holes and countersinking them. The holes are positioned so that the part will sit very precisely between the edge of the saw's tabletop and the back edge of the fence rail. We use short bolts with an Allen head and something called a spot weld center hold tab weld nut. Mine are 3/8 by 16. This size will slip along the rail slot on my Incra TS-LS fence. More of these are used later. Actual construction of the bridge parts is really straightforward enough. Figure out the thickness, the necessary width, and your desired lengths. I used 1 long board. Plane it down to the right thickness and then cut it to the correct width. Figure out if you need any notches cut and then cut them. I used a router. Cut the board to the desired lengths and figure out where you need to drill your holes. Countersink and drill them. This piece is only used during construction. It is used to represent the long piece of wood that is eventually going to be on the edge of the tabletop and which attaches the tabletop to the back edge of the fence rail. Having a short piece on hand allows for precise measurements later without using a very unwieldy board. First, attach a bridge part to the top of the fence rail. Then, determine the dimensions of the mounting rail profile. The piece's thickness should be just a little less than the distance from the top of the bridge part to the bottom of the rail fence. Make the piece 1.5 inches wide. I just trimmed off the 1.5 inch sides of a 2x4, leaving the wider side intact, but a bit narrower. Then I cut that piece to the correct thickness. Finally, clamp the piece so that it sits even with the top of the bridge part and figure out where you need to drill your mounting holes. You'll need some bolts and some more of those spot weld nuts. You'll need 2 of these eventually. Each of mine varied some to avoid obstructions in the saw cabinet. This one is attached to the right side as viewed from the back of the saw. The diagrams pertain just to that one. We'll talk about the left bracket a little bit later. Because I couldn't attach the folding brackets to the saw cabinet, I designed these support brackets. Use 3/4 inch stock for all the pieces. Here's a diagram of the 3 parts that make up the support bracket and how the parts fit together, but no hardware is shown. Soon you'll see dimensions, but use those only as a starting point. Be prepared to cut to fit. The folding bracket attaches to this, so make it first. It must be tall enough to support the folding brackets you have already purchased. 9 inches was fine for me. 4 inches wide should work in most cases. The diagram shows 3 holes on the right. These will match up with the holes in your folding bracket, but don't drill them yet. The size and position of the slots should work in most cases. The slots allow for vertical positioning later. Cut the piece into its rectangular shape. Drill the 3/8 inch holes so they line up in the center of the vertical slots in the first piece you made. Don't drill the other 4 holes yet. Cut a rectangular piece. I had to cut the notch because some saw hardware was in the way. You may not have to do that. Cut the slots as shown. But again, don't drill the 4 mounting holes yet. This diagram shows how the 3 parts attach to each other and then to the saw base. Note that the saw base has 2 holes that you will need to drill later. You'll need a total of 4 of these, 2 for each support bracket. These are L brackets. We'll use them to fasten 2 of the parts at a right angle and keep them that way. Note how the back and middle pieces match up. With the 2 pieces matched up and held with clamps, drill holes in the middle piece to mount the 2 L brackets. Then drill the holes in the back piece. Initially, just attach the L brackets to the middle piece. Using bolts, attach the front piece to the middle piece. Lastly, attach the back piece to the L brackets. Position the support bracket against the saw cabinet so that the front piece just touches the bottom of the fence rail and extends out no further than the end of the fence rail. Use levels to get the bracket square. Use 2-sided tape to temporarily affix some scrap wood to the saw base to mark where the support bracket should be mounted. It's easiest to remove the back piece from the rest of the support bracket and then place it against the saw cabinet, and then use the wood scraps to find the right position and then drill your 2 holes into the saw cabinet. Attach the back piece to the support bracket and then attach the whole thing to the saw cabinet. At first, just use the horizontal slots to get the bracket plumb. Now attach the folding bracket to the front piece. Line up the top of the folding bracket with the top of the front piece. While this photo shows the support bracket almost touching the bottom of the fence rail, it actually must be moved down, as you'll see soon. Attach your mounting rail over the installed support bracket. Use that to determine how far down the support bracket must be moved. Just swing the folding bracket up and down to determine how much clearance you need. As the folding bracket swings, its top must never touch the bottom of the mounting rail. Use the vertical slots to lock it into place. This is a photo of the left support bracket installed. It differs from the right bracket in 2 ways. First, the back piece is made from a 2x4, making the piece 1.5 inch thick instead of just 3/4 inch. This was necessary because when the blade was tilted to its extreme, it would have hit the support bracket. And second, even with the thicker back piece, I had to cut out a notch in the middle piece to allow the motor to completely clear the support bracket. Using the mounting rail's profile as a guide, cut the tabletop edge to a 4-foot length. I had to route a small rabbet to allow the tabletop edge to clear the fence as it moved horizontally. Using the mounting rail's holes as a guide, drill holes in the tabletop edge. As shown here, I drilled a total of 5 holes in the edge. Using 1/4-inch plywood, cut a rectangle that is 4 foot wide and as long as you want your table to be deep. Using the mounting rail as a guide, cut out rectangular holes so that you can tighten the bolts from above. I had 3 bolts located far enough in that I needed those holes cut. Cut a rabbet just deep enough so that the tabletop will sit level with the top of the tabletop edge. Apply glue to the wide rabbeted edge. Clamp the tabletop edge to the tabletop and allow it to dry. Install the bolts and spot weld nuts and the tabletop is ready for the first mock-up. Mount the bridge parts to get an even starting point. Then, using the weld nuts, slide the tabletop along the back edge of the fence rail. It will likely sag at the back. Tighten the tabletop edge to the fence rail. Add necessary wood pieces to the top of the folding brackets so that the tabletop sits level. First, slide on as many bridge parts as you need to make your cut. Normally, I use a shortest piece to the right of the blade and a 24-inch piece to the left of the blade. Tighten them, but not excessively. Swing the support brackets to the up position. They will lock in place. Holding the tabletop horizontally, feed the spot weld nuts through the groove in the back of the fence rail. The first two are kind of tricky, but then it goes pretty easy. Slide the tabletop into its final position. Use a wrench to tighten the tabletop to the fence rail. Here's my critique on the final product. Yes, this is not as easy as the standard fold-up Outfeed tables you've seen, but it is fairly cheap, it's easy to make, and is easy enough to set up and tear down as I could hope for. The 1/4-inch plywood is light enough to manhandle, and I think it will support anything I can throw at it. I was frustrated with not having a good Outfeed table, and for the times that I need them, this one is good enough.